Okay, number 4. Okay, which equation best represents the relationship between x and y in the graph? So here's our x-axis, here's our y-axis, here's our equations. All right, all of these equations are linear equations, and we write those linear equations in slope-intercept form. Okay, this is slope-intercept form because m is my slope and b is my y-intercept. Okay, and we call the slope the constant rate of change. Okay, so our rate of change is our m and our y-intercept is our b. So we have y is equal to mx plus b. So all of these numbers at the end here are my y-intercepts, and those are where my line intercepts or crosses the y-axis. All right, so for the y-axis here, that's our y-axis. This line intersects it right here at 3. Okay, so for my equation, I need this to say plus 3. Well, A says plus 3 and C says plus 3. So I can eliminate B and D. All right, and then I just need to find my rate of change. All right, so a couple of different ways I can do this. I can create a table of values from this graph here. So one of the points I had is 0, 3. And I can use another point here at 1 and 6. 1 and 6. I can even do another one at 2 and 9. So those are the points of the line. And then I can take this table and find out what the rate of change is. And I can do this by subtracting my points. 6 minus 3 is 3, and 1 minus 0 is 1. Okay, so my rate of change is going to be that change in y over that change in x. So that's 3 over 1, which is 3, which would be answer choice A. Another thing I can do is the rate of change. We can find by doing the rise over the run. The rise is how many up I go, and the run is how many over I go. So I would take those first 2 points here, the 0, 3, and the 1, 6, and I would see how many up I'm going. So I'm going up from 3 to 6 is 3 places. And I'm going over from 0 to 1 place. And that's going to give me 3, which again is A, because the 3 is right there. And also I have a steeper line here, which means I'm going to be multiplying by a whole number. For it to be 1/3, it would be like a less steep line. Okay, number 5. Gabriel has these cans of soup in his kitchen cabinet. We have all these cans of soup. Gabriel will randomly choose 1 can of soup. Then he will put it back and randomly choose another can of soup. All right, he's going to put it back. What's the probability that he will choose a can of soup, a can of tomato soup, and then a can of cheese soup? Okay, so with probability, every action gets a fraction. Every action gets a fraction. So we want to know the probability that he's going to choose, all right, the probability that he's going to choose a can of tomato soup and then a can of cheese soup. Okay, so we have to know how many total cans of soup there are. So 2 plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 1 is 10. So we have 10 cans of soup. Okay, so that's my bottom number of my fraction. Every action gets a fraction. Tomato soup has 2 cans, so that's 2 out of 10. He picks that 1 can out, he puts it back, so I still have 10 cans of soup. Now he's going to pick a cheese can of soup. There's 2 cans of cheese soup, so that's 2 out of 10. So every action gets a fraction. and then you multiply. Okay, so 2 times 2 is 4, 10 times 10 is 100. That doesn't match anything because I need to simplify my fraction. I can divide 4 by 4, and I can divide 100 by 4, and 4 goes into 4 once, and 4 goes into 100 25 times. So the probability that he's going to pick a can of tomato soup, put it back, and then pick a can of cheese soup is 1 out of 25, which is answer choice H. Okay, number 6. Corbin made a scale model of the San Jacinto Monument. The monument has an actual height of 604 feet. Corbin's model uses a scale in which 1 inch represents 100 feet. What is the height in inches of Corbin's model? Okay, so we're going to have to set up a proportion to find out because this is a scale model. And our dimensions are inches and feet. So we need to label that inches and feet. Okay, so it's 1 inch represents 100 feet. Okay, 1 inch, 100 feet. The other measurement they give me is in feet, so I want to put that where feet are, 604. Okay, so I'm solving for how many inches that is. All right, so we set up a proportion, we cross multiply. 100x is equal to 1 times 604. So we have 100x is equal to 604. And we divide both sides by 100. We divide the hundreds out. So then we have 604 divided by 100. All right, if the decimal is out of sight, the decimal is to the right. So we have a decimal behind the 4, and we're going to need it for this problem. So 100 can go into 604 6 times. That's 600. Subtract, we get 4. All right, add a 0, bring the 0 down, bring your decimal up. 100 cannot go into 40, so we add a 0, add another 0, bring it down. 100 goes into 400 4 times. Okay, so this model is 6 4/4 inches tall. So to bubble that in, we put this, we're bubbling in 6.04. Okay, so you're going to write your 6 in front of the decimal, going to put your 04 behind it, bubble in the 6, bubble in the 0, bubble in the 4. You can bubble in zeros before the 6 if you want to, but you don't have to. This is all you have to bubble in. When you have a griddable, you want to make sure you work it twice because there's not answer choices to compare to. Okay, so we started off with this proportion of 1 out of 100 and x out of 604, and we're saying that this x is 6.04, which makes sense because they're the same numbers. The decimals just moved twice because we were working with that 100. Okay, so we're good to go.